Hi, this is Jiawei from C.A.T Technologies, and I'm here to explain how our cart works. Three things are needed for this system: a user with a phone, our groceries cart, and a single beacon. Now, to keep it really short, we receive and convert the Bluetooth receivable signal strength indicator into three distance measurements and form this triangle. And what we are interested in is this angle and this distance. There are two main modes for our movement logic: rotation and follow. Now rotation. This part only happens when the card is within following distance, and that means that the card is only expected to rotate about at the same location. This is how it works. Imagine we have this user moving clockwise to this position. This forms a new triangle, depicted in yellow, which gives us a new angle, and that is what we use to subsequently rotate the card. The card doesn't always rotate whenever there is a change of angle. It waits until the angle difference is above a certain mark. Currently, it is set to 15 degrees. As the angle obtained through this method is always acute, you may wonder what if the user moves to the other side of the semicircle. But worry not, Groceries is running on a flipping logic that knows if the user has gone to the other side of the semicircle. Next, follow. This happens when the card is outside following distance, which means that it will move forward to close up the gap. This is also the part where obstacle avoidance comes into the picture. In this part, the angle is not used. Why? Imagine if this card moving forward. As you can see, unless the card is moving along the radius of the beacon, the angle will be constantly changing. Thus, to keep it simple, the angle is not used here to perform rotations midway. Instead, we have our simple obstacle avoidance algorithm to do the trick. Obstacle avoidance. Now, we have two obstacles in our way. The user would naturally maneuver past the obstacles. As for our car, it first tries to move forward to catch up, until, in this case, the right infrared sensor picks up an obstacle. Our card responds by moving towards the right, away from the obstacle. Now, when the sensor is free, the card rotates back for the same amount, while it's moving forward to make up for the rotation. And the cycle repeats until the card returns within the boundaries of the following distance. Here at C.A.T Technologies, we are also dedicated to ensuring that transition happens seamlessly between modes. Here, we show an example for the card transitioning from follow mode to rotation. This is the path our user has undertaken. The card follows, the obstacle avoidance algorithm is triggered, but before the card can correct its angle, it arrives within following distance. In this case, we convert the unfinished rotation into angle and add it back to the angle of the card before running rotation, so that we know that although this is the angle, this is the actual angle of the card. Here's another example of our card transitioning from rotation to follow mode. We have our user rotating in this direction, and before the card has completed rotation, the user decides to move forward beyond the following distance. In this case, the card will convert the remaining angle into rotation time and finish it during the forward motion. Thanks for watching, and have a great day.